Hello and welcome back to the second part of our four-part discussion on math anxiety. Here with me again is Herb Gross, Professor of Mathematics from Bunker Hill Community College and Project Director of a math learning project at Harnett Correctional Center in the central part of North Carolina, serviced by Central Carolina Community College, and Susan Brown, Education Consultant and producer of TeachNet. Herb, when we finished the first part of our discussion, we had moved through the discussion about how many people's problems with math aren't number problems, they're language problems. And had gotten actually to the point where we're beginning to talk about where most people begin to have trouble with math, and that's not addition and subtraction, but fractions and ratios. Let's pick up the discussion there and talk a little more about fractions.
Yeah, what's kind of interesting in terms of language again is you never really have to ever have a problem with fractions. Once you understand, let's do a few interesting things that just popped into my mind just now, so I hope I don't get too vague on this. What does the word teen mean? T-E-E-N? It's basically
Add 10.
So technically speaking, 14 means 4 plus 10.
Right.
Based on that, what should the first teen be?
1 teen.
1 teen after 10. See, 1 teen, 2 teen, 3 teen, and 13 is just a corruption of 3 teen. Where does the first teen come? Not after 10.
After 12.
After 12. Ever stop to think about that? Probably not.
No,
No.
honestly.
Well, the reason I bring that up is that if people are afraid of fractions, they're in good company. Because from antiquity, people were afraid of fractions. And so they invented nouns that had lots of divisors. For example, what's nice about 12 in a dozen is you can make a fractional part of a dozen without breaking anything more easily than if there were 10. See, 10 is divisible only by 2 and 5. 12 is divisible by 2, 3, 4, and 6.
I see. So the reason that so much of things have been given to us from antiquity, like the calendar or the points on a compass.
Oh, I'm glad you mentioned the calendar.
Yeah.
What's the name of the 12th month?
December.
December.
December. What
Only
does
10.
What does DEC stand for?
Yeah.
10.
10.
Nova, 9. How come the 12th month starts with 10?
Good
And
question.
the reason is that originally there were 10 months, each with 36 days, because 360 was a much better number for arithmetic. See, the problem was that the Lord didn't see fit to do it that way. See, with 360 days in a year,
You have
you
to
lost
make
five.
up 5 days.
Yeah, and all of a sudden it's snowing in July. See, stuff like this. So Julius Augustus Caesar reformed the calendar with July and August. But the ancient Greeks knew that, you mentioned the circle before, why not divide a circle into 360 parts? It's called degrees. See, now what happens is you say, suppose you want to talk about 1/3 of a circle. That means dividing a circle by 3. See, 1 divided by 3 isn't the whole number. But what's another name for a circle? 360 degrees. 360 divided by 3 is 120. 120 degrees sounds like a whole number. It's a whole number of degrees, but a fractional
Right.
part of a circle. And when you say a half dozen donuts, you're thinking of 6 donuts, even though a half is a fraction. This goes on all the time in mathematics. You know, people have said to me, how come you pick 5,280 feet to be in a mile? Wouldn't it have been easier to set 5,000? Well, see, 5,000 breaks down into 5 times 1,000. 1,000 is 10 times 10 times 10. And again, all you have is 2's and 5's as factors. But 5,280 can be divisible by 2, by 3, by 4, by 5. And so when you talk about a whole number of feet, you're talking about a fractional number of miles, but you never even notice it.
So the ancients were smart enough to create units of measure that were easy to do the math in your head.
Yes, yes. And in fact, it goes back to learning any, remember we said that math is a language? It goes back to learning any foreign language. Let's pretend now that you've never learned Spanish before, or German or anything. English is your natural tongue, and if people want to pick a different natural tongue, just visualize that you're taking a foreign language. And you take and the teacher asks you a question in the foreign language. Let's suppose English is my language. The teacher asks me a question in Spanish, and she wants the answer in Spanish. Where am I more comfortable, in English or in Spanish at this stage of my career?
Definitely
English.
English. So what do? I hear the question in
Spanish.
Spanish and translate it into English.
Then you
Now I'm
find it.
comfortable in English, so I answer the question in English. Then I translate the answer back into Spanish. And when you leave out steps 2 and 3, in other words, when you hear the question in Spanish and answer it in Spanish without thinking about the English, that's when you're bilingual. Though I had a very interesting different answer given to me once. I had a Vietnamese student in class who told me that she thought she was bilingual the first time she dreamt in English. And I never thought about that before. What language do you dream in?
Yeah.
I was going to make up a sick joke. I was going to say, I asked her what the dream was about, and she was going to say, I don't know because it was in English. Yeah, but but you see what I'm saying?
Yeah.
So let's summarize those 4 points, because I'm going to show you how that applies to mathematics in a second. So it's you hear in the foreign language. Here in the foreign language. Translate. I'll just abbreviate this because it takes too long. You translate into your own language. You answer in your own language. And then you translate back. Is that clear enough? Translate back. Okay?
4 steps.
4 steps. Hear it, translate, answer, translate back. Pretty simple? Okay.
Very simple.
Okay, let's apply that to fractions. See, I told you at the end of our last lesson, we were talking about 1/7 basically means you divide by 7. So what do you imagine 1/4 would mean?
Divide by
That's
4.
1/3,
Divide by 3.
1/3. Yeah, divide. See, language problem again. So suppose somebody said to me, how much is 1/3 plus 1/4? Now, what's the other thing we said? Before you can add, these are still numbers, aren't they? Before you can add, they have to modify the same noun.
Right.
1/3 means we're going to divide by 3. And therefore, if we don't like fractions, we should pick a noun that's divisible by 3, like 3, 6, 9, 12, 15. Hence the motivation for learning multiplication tables. When I say count by 3s, that's a whole number problem, not a fraction problem. 1/4 means I'm going to divide by 4. That means I want a noun that's divisible by 4. 4, 8, 12, 16, etc. But I can't add these unless they modify the same noun, right?
Right.
Right?
So I need a noun that's what? At the same time, divisible by both 3 and 4. There's another thing that's interesting about multiplication. When you say to a kid, how much is 3 times 4? We call it the right answer if the kid says 12, which is true. What I want a kid to realize is that this is an abbreviation that says the 4th number you come to when you're counting by 3s, and the 3rd number you come to when you're counting by 4s. And by the way, notice how that makes them
Sure.
review. See, 4, 8,
Back to
12.
the fingers
Sure, back
again.
to the fingers
Yeah.
again. Back to the fingers again. So in other words, 3 times 4 is the 4th multiple of 3, the 3rd multiple of 4. So 12 would be a nice noun to pick here. What comes in 12s? Well, dozens. Dozens. And since everybody hates math, let's sweeten it up by calling it a dozen donuts. So now, now I hear the question as, I'll abbreviate dozen donuts just by the word dozen, so that we have enough room without having to rewrite the line. I have 1/3 of a dozen plus 1/4 of a dozen. The problem is these adjectives are fractions. I don't like fractions, so I will change the noun that will allow me to convert these adjectives into whole numbers.
Okay.
You follow the idea? See, what's another name for a dozen donuts?
12 donuts.
Is it a whole number problem or a fraction to divide 12 by 3?
It's a whole number.
Whole number. 12 divided by 3 is 4. So translating from the foreign language, see the fractions, into whole numbers, 1/3 of a dozen means 4 donuts. I'll spell donuts the abbreviated way. What's a dozen donuts is still 12. 1/4 means divide by 4, 3 donuts. Now, how hard is this problem to solve if we assume that whole numbers are our natural tongue?
Very easy.
Sure,
Very easy.
4 plus 3 is 7. Whenever 4, 3, and 7 modify the same noun, so the answer must be
7 donuts.
7 donuts. Problem is, if we want to leave the nouns out, we can't do that unless they're all the same. Otherwise, we can wind up with 3 plus 2 is 40 again, as we saw in the first lesson. So in other words, 7 donuts is a whole number of donuts. Is it a whole number of dozens?
No,
No,
it's a fraction of dozen.
What fractional part is it? You have 7. How many do you need?
Out of 12.
12.
Out of 12. So that's 7/12 of a dozen. Now can I cross out the dozen and say 1/3 plus 1/4 is 7/12? I don't think most people were taught this way. See, the way I was taught was something like this. See if this sounds familiar. You wrote down 1/3, then you wrote down 1/4. Then you picked a common denominator. They were called Gazinta problems. 3 goes into 12 4 times.
Right.
4 times 1 is 4. 4 goes into 12 3 times. 3 times 1 is 3. Then you were told to add the 2 top numbers and keep the common denominator. Remember doing that?
Yeah.
Yeah.
Well, see, this was
That's how I
exactly the
learned.
same. Doesn't this look like fractions now? Can you see this okay?
Yeah.
See, this looks like fractions, doesn't it?
Right. Which
But-
people can't do.
Which you can't do. But all this says is at a rate of 1 out of every 3, you're taking 4 out of every 12. See, when you said that 3 goes into 12 4 times, you said there are 4 bundles of 3 in 12. And since you're taking 1 from each of those 4 bundles, see, 1/3 of a dozen is 4 of the 12, meaning 4 donuts. See, 4 goes into 12 3 times. In other words, there are 3 groups of 4. You're taking 1 from each of those 3 groups. This is just another way of saying that the 4 donuts plus 3 donuts is 7 donuts.
But your method of explaining that using the donuts gives nouns that are familiar to the student to understand.
That's right.
So he can go from math to donuts,
That's right.
answer
That's
it in
right.
donuts, and go back to math again.
That's right, and that's the 4-part.
That's the 4-part thing. Now, there is a problem to what I just did, because not everything comes in 12. See, suppose somebody else said to me, hey, what if you were given 1/5 plus 1/7? See?
Then you have
12
to-
isn't divisible by 5, 12 isn't divisible by 7.
Pick another noun.
Pick another noun.
Right.
See, for 1/5, you want something that's divisible by 5. For 1/7, you want something that's divisible by 7. So to get a common denomination, you want something that's divisible by both 5 and 7. That's going to be our old friend, meaning what? Multiply the 2 together, that's 35. Kid says, but I don't know of anything that comes in 35s. What comes in 35s? Hey, it's my problem. I'll make up what's going to come in 35s. I'm going to put 35 books in the carton.
Okay.
Can a kid relate to that? I
Sure,
think so.
sure.
So in other words, now the 1/5 and the 1/7 is going to modify carton. Now, how many books are there in the carton?
35.
See, 1/5 is a fractional part of a carton. Is it the whole number of books now?
It's a whole number of
Sure,
books.
it's 7 books. See, because 35 divided by 5 is 7. Whole number problem? A fraction problem.
Whole number.
See, 1/7 of a carton, 1/7 of 35 books. 1/7 means divide by 7, 5 books. Therefore, the answer is 12 books. Why? Because we know how to add whole numbers when they're modifying the same noun. How many books were there in the carton? 35. So this is a fractional part of a carton. What fractional part is it?
12 out of
the 35 that
35.
you need. Now, I just did this in a few minutes, didn't I? The average kid, when they learn fractions, has half a year to learn this. Can you imagine how intuitive you could make this? See? And what's interesting is, it seems like we're spending a lot of time on this. In reality, all you have to do is 2 or 3 problems this way, and the kid will get the knack of it. I think the example I always like to use is if I'm stuck at a phone booth, and I'm calling you up, and I run out of change. I say, Sandy, call me back. I'm at 762-1528. You don't have a pencil. You keep saying 762-1528, 762-1528 until you call me back. Now, 5 minutes after you call me back, you've probably forgotten that number because it had no relevancy to you. Suppose instead I said, Sandy, call me right back, and you better get a pencil because this is hard. I'm at 222-2222. You don't mind if not. See, what I claim is that by teaching by rote rather than by letting the student relate to it, we're teaching everything as if it was 762-1528 instead of 222-2222. And what proof do I have of that? What is the usual drill we give kids after we've taught them a new concept? Go home and do 7,000 problems like this. Why? Because if you don't, you won't remember what it is to call me back with. And that's why I make the sarcastic comment that in many cases, the student who passed math was the one who was lucky enough not to forget it until after the test was over, and the one who failed it was unfortunate enough to forget it before the test was over. But notice how you can build on these concepts now.
Interesting thing about that, Herb, to me is all of us have been in some discipline or another where, at least for a few weeks, it was a foreign language.
Exactly.
And,
exactly.
So that maybe there's chemistry anxiety, maybe there's physics anxiety, maybe there's English literature anxiety as well, as long as it's a foreign language to you, and the course is taught that way. And it occurs to me that the way most of us are taught math, that is just with the fractions, not with the nouns, is a little bit like going into an English class that's taught strictly in Portuguese. Everybody talks
Sure,
in Portuguese,
sure.
and you're expected to understand.
Sure. Now, by the way, I should make a disclaimer here also. It's something I call the horse and rider syndrome. See, when you want to train a horse to give kiddie rides, you have a trained rider get on the horse, and he rewards and punishes the horse until the horse follows that path. Once the horse memorizes that path, when the kid gets on the horse, the kid thinks he's riding the horse, but the horse is just going where it was trained to go. The excitement begins when a new skilled rider gets on the horse and wants to take the horse someplace else. Either the rider gets thrown or the horse gets broken. Now see, my claim is that each of us has a horse and a rider. The horse is our intellect that says, I understand what you're talking about. The rider is that. The horse is the part that doesn't let us change, the inertia. See, when one of my kids sees, you wouldn't know by looking at me on television, but I tend to be short, fat, and bald sometimes, okay? And I have a weight problem. I have a weight, not on radio, but on television. I have a weight problem. My kid will see me eating a cookie. Say, Dad, you don't need that. I say, hey, you're talking to the rider. Tell the horse. See, the horse is the one that says to me, hey, Herb, don't listen. Thin people die too. See, the horse is the one that says, don't worry about losing the weight. See, the horse is the one that says, hey, Herb, you've been overweight by 60 pounds for 30 years, and you've dieted this whole day, and it hasn't worked, so let's just give it up and go back to the way we're comfortable. So keep in mind that as I'm showing you what we're doing this way, if you've been working the old way for a number of years, your rider is going to like what I'm doing. Your horse is going to say, there's more to it than what meets the eye. He's trying to trick you. And in fact, if it doesn't do that, you're going to become very, very angry. You would think that if you were suffering with something for a long time, and I showed you, hey, you never had to suffer with this is the way to do it. You say, guy should be grateful. No, the guy is angry, because why was he harassed all this time? And
Is
so
that
to
your
ju-
experience with the students at Harnett and other correctional
Other correctional
centers?
centers.
No kidding.
See, and in fact, rationalization is a wonderful thing. Remember, that's what the cannibal said to the missionary. If God didn't want us to eat people, why did he make them out of meat? Okay. See, students will say something like, show me one place in the real world where I'm ever going to need algebra. That's when they're talking nice to me. They say other things too. Okay. That's not being insolent. That's a cry for help. See, what that student is really saying is, hey, the next best thing to being good at something is to be convinced that what you're bad at wasn't worth knowing in the first place. So if you can't show me a place where this is useful, I'm not dumb for not knowing it. See? So if I say to that student, hey, I'm the professor, and who are you to question me? The main reason you got to know this is that on Friday's exam, there's going to be 7 problems, and 5 of them are going to be on this. Well, that's a heck of a motivation if a kid wants to pass. It doesn't really mean that much. See, now the kid is saying, big deal. They call him smart when he teaches something you don't need. See, the real interesting thing is, if you have patience with that kid, and this has happened to me both at Bunker Hill and with the prison, here's a guy going from math anxiety into all of a sudden saying, can you help me get into MIT? There's nothing in between. You see a kid who hated long division. Now he understands it. You would think that if you understood something, after you did 5 problems, you'd be tired of it. These guys want to do 100 problems because they've never had success with it before. Let me watch this stuff. I have to pull them off of it to try something new. And by the way, we're just talking about fractions. We haven't talked about decimals. See, that's another interesting thing too. Decimals are another language.
Yeah.
This is true. Remember I said to you in the first lesson that a lot of my knowledge and how I try to teach people comes from my own anxiety? It was the first time I walked into a classroom and a teacher had corrected the paper other than on a scale of 100. There were 14 problems, and the teacher wrote down 11 14. So I had 11 right out of 14. Well, I knew 11 out of 14 was pretty good, like in dividing candy. That was 11 for me, 3 for him. 11 for me, 3 for him. But I didn't know if it was good enough to get an A with. You see, aren't we used to wanting to hear things on a scale
Of
of
100.
100? Or sometimes on a 10. Like in the movie 10. It's like saying, I fixed you up with a date. The guy says, what kind of a date? I said, I got good news for you and bad news. The good news is she's a 10. The bad news is a perfect score was 12 million. Okay? See, 10 on the scale of 12 million doesn't mean much. See, but on a scale of 10, 10 is perfect. So a lot of times what might happen is, let's suppose you have a test with, well, we'll pick something that has no remainders for the time being, because this is not supposed to be a math course. It's just supposed to give you an idea of what's happening. See, so suppose you get 4 right out of 5 on a test. And you say, well, at the rate of 4 out of 5, what would that have been on a scale of 10? That your Gazinta problem again. Right. 5 goes into 10 twice. 2 times 4 is 8. So in other words, on a scale of 10, that would have been worth 8 points. Guys, what if it was on a scale of 100? 5 goes into 120 times. 20 times 4 is 80. Now, see, this is what? 8 per 10. 80 per 100. Okay? The Roman word for 100 is centum, centum. So percent means per 100. See, so when you say you got 80%, that means you got 80 points out of every 100. See, and that's called a rate. For example, can you picture this? I'm driving, all of a sudden traffic cop comes up behind me. He says, you were speeding. I said, how fast was I going? He said, you were going 70 miles an hour. I said, that's impossible. I've only been driving for 8 minutes. Has that ever bothered you that way? What does 70 miles per hour mean? It means if you continued at the rate at which you were driving, in 1 hour you would have driven 70 miles. See, it's a rate problem, and that brings up division, and division brings up remainders, and remainders are fractions. See, now what happens is decimals are just a place value way of taking care of fractional parts. You see, in regular place value, what are the denominations? Ones, tens, hundreds, thousands, right? Now, suppose you put a mirror over here and put the, see, what would you see over here? Tens,
right.
hundreds,
Hundreds, thousands.
Okay, now we'll just put the word per over here.
Okay.
See, so when you're counting on this side, it's per 10, per 100. So if I write down, see, we'll put a decimal point here, just because when the nouns aren't here, you can't see them. What we're going to do is, we're going to say, if I write down 0.8, that means what? This is the first digit,
8 per 10.
8 per 10. We call that 8/10. If I put down a 3 over here, without the decimal point, you'd see 83. 83 what? 83 per tenths, hundredths. In fact, the mechanical way to do this is leave the decimal point out. Put a 1 down here and count the number of digits. 1, 2. See, now I've become trilingual. I've translated from a decimal to a fraction. This says 83 per 100. That's 83 for me, 17 for you. That's not a bad rate. Now I'm going to tell you a true story. Had a student come to me once who wanted a grade change from another instructor. I was her advisor. And I said, why do you want your grade change? And she said, so I can make the dean, I want to make high honors for I want to make honors for graduation. So I first started lecturing moralistically. In other words, if the only way you can make honors is by me changing your grade, is it really honors? And we talked about that, but I could see she was really upset. She was really, really concerned. And I felt badly about that. So I looked at the transcript of grades. And I could see it was nowhere near a 3.5, because that's what you need for honors in our school, 3.5. I said, honey, are you sure you have a 3.5? Oh, she says, I'm way higher than that. I have 3.16, which was, by the way, reason enough not to change the grade, you understand? You see, but look what I'm saying over here. If you're taught mechanically over here, see if we can look at this. I write down 0.16, and somebody else writes down 0.5. Do you see the adjective noun again? See, this is 16, but 16 what?
Per 100.
Per 100, see, 2 digits. This is 5 per 10. Now, by the way, a little kid would see this as saying what? Let's divvy up the candy this way. 16 from 100 is 84. That means 16 for me, 84 for you. You don't have to be too bright to recognize that this distribution gives away more than you're keeping. What does 5/10 mean? 5 from 10 is 5. That means 5 for me, 5 for you. And this is breaking even. See, breaking even to a kid, half means what? I keep just exactly as many as I give away.
It's fair.
See, kid doesn't have, see, this is nothing that bothers me. I don't know if this is trivial or not. You go up to a young kid who's never seen fractions before, and you say to that kid, which is more, 2 over 3 or 4 over 15? Well, that kid, he doesn't know what these things mean. He said, let's see. This top number beats this top number, so this one's winning 1-0 so far. This bottom number beats this bottom number, so that's 2-0 so far. 2 plus 3 is less than 4 plus 15. That's 3 victories so far. 15 take away 4 is more than 3 take away 2. Kid says, no matter how you look at it, 4/15 is more than 2/3. Now I say to that same kid, you're divvying up candy with your little sister, and you like the candy. Which is a better deal? 2 for me, 1 for her. Okay? Or, see, 4 from 15 is 11, right? 4 for me, 11 for her.
And right away, he can see which is the better
Yeah,
deal.
now one kid ever says 4 for me, 11 for her. They say the top one, 2 for me, 1 for her. So I say to them, but isn't 4 more than 2 and 11 more than 1? They say, yeah. But if it's 2 for me, 1 for her, I'm keeping more than what I'm giving away. But if it's 4 for me, 11 for her, I'm giving away more than what I'm keeping. I say, wonderful. Now, which is bigger? 2/3 of 4/15. Just 4/15. Because you see, he knows the concept.
But he has a
See,
language
he knows the
problem.
cat is black. He doesn't know El Gato es Negro.
Right.
So why shouldn't there be a problem that way? That's all I'm saying. And about mixed numbers, you see, the Gateways course that I do, that teaches in detail what we're doing over here. The purpose of what we're doing now isn't to replace a math course. It's to have people have the confidence that when they are in a math course, okay, that there's hope. There's hope. In other words, once you understand something, by the way, people have said to me, isn't there a chance that after you've learned something your way, you can still forget it? The answer is yes. But the difference is, when you know for yourself that you knew something once, and then you forget it, you say, I can go back and relearn it. When you never understood it, the whole thing is lost. You see what I'm saying? So my feeling is, I'm not saying this is a great way of doing things, but it works for me. If I believe that there's a language problem, what I'm going to do when I teach is I'm going to make sure that the student knows how to translate from the unfamiliar language into the familiar language. If by definition of what I mean by familiar, if the language is familiar, the student will be able to solve the problem in that language. Then they translate back the answer into the unfamiliar language. And after a while, they will become bilingual this way. So have we missed anything to summarize up with? We have about a minute
Well, in
or
the first section, you argued that most math problems are language problems. Then you showed if you know how to count, you can do addition and subtraction. Then you showed if you can work in whole numbers, you can work in fractions,
Right.
as long as you have the vocabulary to work in it. So I guess the lesson is make sure you're doing with the right vocabulary when
Right,
you teach
right.
and when you learn math.
Right. And I think this is fun. As I say, if anybody is having trouble getting used to this, have patience. It takes time to retrain the horse.